started. My goal today is to finish this general, and that's basically us done. So what's going to happen is on Thursday, we'll be reviewing for the final. Monday we'll also be reviewing for the final. Thursday, I expect you to be here. If you're not, you won't get attendance. On Monday, the following Monday, I'm making that much more open-ended because I think by this point, you need to decide what's best for you. So if you want to not come on Monday, that's fine. I'll still give you attendance for turning, for being there. I'm just going to assume that you're studying for the final. If you want to just turn up on Monday to ask one thing that you've been looking at and don't know, get the answer, you're happy with it, you can just leave again, right? So it's very drop in and drop out whenever you feel like it on Monday. But on Thursday, we'll make it a full class day where we can, go through some topics, and that way I can make sure that everyone knows what's happening and we're all in the same spot. Okay, let's start with one of the homework questions on the chain rule. Here we have a function in x and y, where x and y are both in t. So this one we've really tackled before. And let's just find dz by dt. And that's going to be dz by dx times technically dx by dt. And then the partial derivative of z with respect to y times dy by dt. If you differentiate this expression with respect to x, that guy there gets you y to the 6. And if you differentiate x with respect to t, you get 2t. And then I made a mistake there. That guy does get you y to the, where's my brain today? Gets me y to the 6. Take away 2xy there. That's much better. And then you differentiate this guy with respect to t. And then you go through and you do the same thing, but this time with respect to y. So that's going to get you 6xy to the 5. And with respect to y, that's going to get you negative x squared. And then you finish with times dy by dt, which is also 2t. And in this case, I'd pull out 2t as a common factor, and that would leave me with this expression. And the good news is that WebAssign is accepting that mixture of x, y's, and t's, because I've essentially got the answer in front of me, and it says that. Okay. So let's look at a different one. What should we look at? Let's look at 4. So we're going to be using this chain rule, adapting each situation to whatever we've got. This one is the sine of x cosine of y. And x is going to be the square root of t, and y is going to be 4 over t. And we are going to find dz by dt. So the chain rule says you get that guy times dx by dt, and then you get this guy dy by dt. And I think I said that yesterday. You can think of this as the contribution to the answer that you get from the x's in the formula, and this is like the contribution of the answer you get with y's in the formula. Now, this fella here is pretty easy. If you differentiate a partial derivative with respect to x, that's the only variable in town, that's just a constant. So what you get is a cosine of x cosine of y times the derivative of this guy. Okay, if you want to differentiate the square root of x, you probably should call it t to the half, shouldn't you? Now, if you do that, you get 1/2 t to the negative a half, and we'll come back to that there. Now, if you do this fella, differentiating a cosine gets me a negative sign. Should go ahead. So I'm going to have this guy, that guy. And if you differentiate this guy, you're going to trust me, but that's what you get. So it looks like we're going to have 1 over 2 square root of t times this guy. Take away, 2 takeaways make it an add then. 4 over t squared times that guy. And let's check. Yep, WebAssign's happy with that answer. We don't need to turn anything into t's.
So just a silly question,
Yeah,
but the cosine x and cosine y don't combine to become cosine squared, right?
correct.
All right.
The only time they would combine is if they were both x's, and then it would combine as a cosine squared.
All
But
right.
since one is an x and the other is a y, they don't play well together. They don't do anything. So that was 4. Guess I'm picking on even ones today. Question 6. I have z equals x minus y to the 7. And x and y are both functions of another 2 different variables. X is s squared t, and y is s t squared. And we are going to find, well, they ask you to find both, but we're just going to find one of the 2. So for no particular reason, because I want to, I'm going to go for that one. So if you want to find the derivative of this with respect to this variable s, what you're going to do is differentiate it with respect to x and then do a dx by ds. And then you're going to differentiate z with respect to y and do a dy by ds. Now, if you differentiate this guy with respect to x, you're going to get 7 lots of x minus y to the power of 6. Technically times the derivative of what's inside with respect to x, but since that's 1, I'm not going to bother. Finishing with the derivative of x with respect to s. If you differentiate x with respect to s, this gets you 2st. Now, if you do this fella, you got to be careful. I'm about to do a deliberate mistake. Oh yeah, I know how to differentiate that. You get 7 lots of x minus y to power of 6. And then you multiply by the derivative of this fella with respect to s, which is t squared.
That has to be a negative now?
Yeah, there has to be a negative, Lewis. And that's because it technically is a chain rule, and the derivative of the inside function with respect to y is a -1. So there's really a negative there, or a -1 if you prefer. So I'm now going to do 7 lots of x minus y to the squared. Oh no, I'm not. But too late to change it. Right. This guy here, I should have taken care of it. So it's 14. I'm going to put the st in the front. Now I'm going to do x minus y to the 6. And this guy, I'm really not doing much. There. I probably should have went from this line straight to that one. Now, style points. Make it look like the original, factor the heck out of it, and last but not least, if it's a trig function, try and find a trig identity that makes things look good, right? That's your goal. Now, since there's no trig functions here, I don't need to worry about the third one, but I do need to figure out how to make this as nice as possible, right? Style points. And I'm thinking factors, factors, factors. So, right, we're going to factor the heck out of it. I don't care how many lines it takes, as long as we do everything that can be done. So throw a common factor out and I'll start pulling them out. What you got?
7t.
Agreed?
The x minus y to the 6th power.
Agreed? Double check. I think we've got everything. Would you agree? There's none left. So I'll just do a big bracket and see what we have. 2 left over. S left over, used up, used up. Take away, used up, T left over, used up. So I guess my bracket didn't need to be anywhere as big as it is. You don't need to do this. This is me. Nicest version of the answer we can get. Comfortable? Can you imagine, we're not doing it, but could you imagine doing dz by dt in a very similar way and probably getting very similar factors as well? Okay, pause for a minute. Any questions? Things going smooth? Okay. Oh, I have to do this. I know I'm been sticking to the even, but not this time. Z is equal to the inverse tan of x to the 4 plus y to the 4. And x is a function of s and t, s natural log of t for that guy, and y t e to the s. And it really doesn't matter, they're both equally ugly, so let's do the partial derivative of z with respect to t. Okay, somebody tell me the chain rule combination that you would use to get that guy. How would you get that guy? I'm ready. Go for it.
The dz over dx,
Followed by,
dx over dt.
yep. Moving on then. dz by,
dy.
yep. And then dy by dt. There is a logic to this formula, isn't there? It's not just random letters thrown out everywhere, right? It does have a flow to it. That's the flow for this one. Now, God in Himmel, would you look at that ugly question? Which is the only reason I picked it. The minute I saw it, I thought, no, I'm not missing this guy yet. But this guy has got a lot of pieces that are not going to play well. So let's find just that guy. The partial derivative of this ugly expression with respect to x. Okay, first question then. What is the derivative of an inverse tan?
1 plus 1 over 1 plus x squared.
Right. So it's now going to be, instead of x squared, we're going to call that. So it's going to be 1 over 1 plus that guy squared. So far, so good, right? 1 over 1 plus x squared, 1 over 1 plus ugly guy squared, right? The inside function, essentially. But that's not all. Isn't this a chain rule itself, a different kind of chain rule? Do we now have to differentiate the inside function with respect to x, which means you get another 4x cubes out of it. Now, we have this fella. Well, the derivative of this expression with respect to t is just s times 1 over t, which I'm going to call s over t. At least that wasn't too bad. Now, if you do the next term, isn't it almost identical looking to this one with one exception? You're going to end up with a 4y cubed on the top, but you are going to have a 1 plus x to the 4 plus y to the 4 all squared on the bottom. And then times, well, if you differentiate this guy with t, you get e to the s. Okay, time to try and make this vaguely nice. There's no way in the world this is going to be pretty, but let's at least put some makeup on it, right?
Wouldn't the derivative of y be e to the s times t to the es?
This one here,
Yeah.
With respect to t,
because it's a chain rule or a product rule.
well, it isn't really, because this is t and this is just a number.
Oh,
So when
okay,
you
okay.
differentiate it, you just get this guy.
Okay.
But we have to have that partial differentiation kind of thought process
All right.
when we do these. Right. Look at this expression. Is there anything you can see that I can pull out as a common factor?
The 1/1 plus x to the 4 plus y to the 4, all of them squared.
Agreed.
And I believe that I could pull out a 4 on the numerator.
Okay. I think that's about it. Let's see what's left. The bottom's used up. That 4 is used up. There's still an x cubed, an s, and a t. Yeah. Plus, bottom is used up. 4 is used up. There is still a y cubed e to the s. And the only good news I can tell you is that's what WebAssign is happy with. That is ugly. Agreed. I mean, but it's less ugly than that, right? We'll give it that. Technically, I would never like to see a fraction with a fraction in it. But I think sometimes you just have to go with the flow and say, nah, it's not worth it. It's not worth the effort. Because to try and fix that, I might make it even worse looking, you know, by trying to fix one little thing could make it just disintegrate into some really horrible combination. Well, that's as good as it is. So, next fella, let's go on to odd ones then. Let's do 9. Z is equal to x to the 4 plus x squared y. And x is now a function of s, t, and u. And y is a function of s, t, and u as well. And they ask you to find all 3, but we'll just pick one of them. So how about dz by du? Let's do that one. No, I'll have to do it down here. I'll need more of them. There is where we're going to do a chain rule formula. You notice that there's 3 pieces because there's 3 variables here. Okay. And I just made an oopsie. There's only 2. I just realized it. Okay. Anybody want to tell us the combination for this one?
Is that the dz over dx times dx over du, right?
Yeah. And the next one?
And it is d z over dy times dy over du, right?
Yeah. The reason why I thought there was 3 because there's 3 here, but this is the thing that decides how many you've got. Right? If there's an x, y, z, there'd be 3 pairs, but there's only an x, y. So this can have 10 variables if it likes, but this one is the one that decides how many pairs there are going to be. Not the worst looking thing to differentiate. With respect to x, you're going to get 4x cubed plus 2xy. And then you differentiate this guy with respect to u, which actually just gets you -1. And then you go back to the original z and you now differentiate it with respect to y. And you get x squared. What happened to the x to the 4 when I differentiated it with respect to y?
It doesn't have y with it.
Big fat 0, right? Doesn't matter. Finishing with this fella with respect to u gets you 2st. Yes. And I I guess I shouldn't leave that around. So how about negative 4x cubed plus negative 2xy plus 2STU x squared. I don't think there's anything worth doing to that. I guess you could pull out a common factor of 2. Oh, you could do more. I take it back. I can do more than 2. What else could I pull out?
X.
Yeah, so I think in this case it's worth it. If it was just 2, I wouldn't have bothered. So that's going to leave me with negative 2x squared, negative y, and that's used up, and one of them's used up. So that gets me an STU and an X.
Stugs.
Yeah, stucks. Sounds like it should be a word, like it sucks. Okay. Are we good, guys? I mean, this is a process. They just change how many variables there are and, you know, then how many things the other things in terms of. So let's, I've done 10's just long. Let's see what 11's got in it. 11's interesting. W is xy plus yz plus zx. I'm getting a familiar look to this one. X is going to be r cos theta. Y is going to be r sin theta. And z is going to be r theta. And let's find that one. Now, you always go in pairs, right? Something times something, right? This one had 2 pairs. How many pairs are you going to get out of question 11?
3.
3. I don't care that that's got 2 variables, 1 variable, or 10. These are the guys that tell you you're pairing. So it's going to be somebody, something, somebody times somebody, plus somebody times somebody. And we know that these guys are all going to be DWs, right? So it's really just a matter of, you know, filling in the pieces and we're good to go. Now, since there is an X, a Y, and a Z here, there's going to be an X, a Y, a Z here, right? And for each one of these, you do an X with whatever that variable is, you do a Y, whatever that variable is, and you do a Z, whatever that variable is. So there is our formula for a 3 variable matching a 2 variable. Differentiate that with respect to X. You get a Y, you get nothing, and you get a Z. And if you differentiate this guy, which is him, with respect to theta, you get a negative R sine theta. So that's my first pair. My second pair is differentiate this with respect to Y now. So you're going to get an X and a Z, and then differentiate this with respect to theta, and that's going to get me an R cos theta. And I don't have enough room, so I'll put it down here. If you now do back to here again, but use Z, you get a Y plus an X, and you differentiate this with respect to theta, you just get an R. Okay, style point, 3 terms, common factor. Can you see
R.
anything? Agreed. Is that about it? I would think so right now. So let's see what we get left. We're going to have a negative sine theta times a Y plus Z. We're going to have a positive cosine theta times X plus Z. And we're going to have a Y plus X. And I guess I could distribute them, but if I did that, it would be even bigger. So I'm not going to bother. Now, that would normally be the finish, but not now. This question tells you what R and theta are equal to. And so you're being asked to find the value of this when r is 4 and theta is pi upon 2. And you always differentiate first before you plug in the numbers. If you plug in the numbers first, you'll end up with 0 every time, because all you'll get is a number, and differentiating a number gets you 0. So you kind of know that would be a bad idea. Now, I know there's all sorts of pieces here, and some of them are obvious and some are less obvious. That r equals 4 is obvious. And I guess these guys here are reasonably good. But the guys that are less obvious is I need to do x, I need to do y, and I need to do z. So I know that x is going to be r cos theta. So that's going to be 4 times the cosine of pi upon 2. And whatever that number is, that's what x is going to be.
0.
Oh, well done. Yeah. And this is going to be 4 times the sine of pi upon 2. And I believe that gets you 4, right? And this one is going to be r theta. And this is just going to be 4 times pi upon 2. So that guy is pi upon 2. So you see, I now have a value for x, a value for y, and a value for z. Right, so I'm ready to start plugging this into this fella. So it's going to be r, which is 4, negative the sine of pi upon 2 times y plus z becomes 2 pi and 4, right? So that's 4 plus 2 pi. It's that piece done. Right, middle one. Cosine of theta becomes the cosine of pi upon 2 times x add z. That's 0 add 2 pi. X add z. And then the third piece is just y plus x, and that's 0. Oops, wrong one. That's 4 plus 0. Okay, let's take this a little bit further. The sine of pi upon 2 is 1, so that's negative 1 times this guy. The cosine of pi upon 2 is 0, so 0 times that doesn't matter, you get 0, and 4 plus 0 gets me 4. If I distribute the negative 1, they 4's cancel, and I'm left with 4 times negative 2, which is negative 8 pi. And the good news is I can see the answer and it is negative 8 pi, so I did it right. I would be cool with evaluating a partial derivative at a given value of, in this case, r and theta. Find out who the x, y's, and z's are, because you need to know them as numbers. And then take your answer with all the jumbled up guys and replace r's and thetas by what they are, and x, y's, and z's by what you found out there. And then it's just, you know, keep going until you get it to the bottom line. Any questions? Okay, you're going to get one from me. So I hope you're ready for this. Z is equal to x sine y plus y sine x. And x is going to be r squared plus theta. And y is going to be r theta. And your question is find the value of the partial derivative dz by dr when r is 1 and theta is pi. And you have got 3.5 minutes from now. No pressure. Go for it.
Is it with respect to theta or r?
dz dr. Right. Thirty seconds. No pressure. Should have that tick tock, like they have in countdown. Okay, I'm going for it. Hopefully you can catch up towards the end if you're almost done. So we're going to find the derivative of z with respect to r. Now, let's see how that's going to work out. dz by dx, dx by dr, and dz by dy, dy by dr, the chain rule. Now, if you differentiate this guy here with respect to x, this piece is going to get you sine y, and this piece is going to get you y cosine x. Then you finish with the derivative of this expression with respect to r, which is 2r. Then you go on and you go back to here, but now you do the derivative of z with respect to y. So this guy gets you x cosine y, oops, plus sine x. It's a funny plus. And then you finish with the derivative of this guy with respect to r, which is here. So that's the differentiation step done. What I'm now going to do is evaluate it when r is 1 and theta is pi. And we'll see what kind of guys we get out of that. So I'm going to find out what x is equal to. It's r squared plus theta. So that's 1 squared plus pi. So that's what x is. And y is just going to be r times theta, which is 1 times pi. So that's what y is going to equal to. And back to the side. It's now going to be the sine of pi plus pi times the cosine of 1 plus pi, multiplied by 2 times 1, which is 2. Not enough room here, so plus x, x is equal to 1 plus pi, cosine of pi plus the sine of x. So that's the sine of 1 plus pi. So that's all of that stuff. And multiplied by theta, which is pi. Again, getting close to the end. The sine of pi is 0. Can't really do anything to that guy except write it down as 1 plus pi. Still times 2. Plus, what's the cosine of pi?
-1.
So we're going to have -1, 1 plus pi, added to something you can't really do much about, times pi. Well, if I multiply this fella out, you get 2 pi, the cosine of 1 plus pi. This guy gets you -1, pi, oops, times pi. So you get that guy and that guy. And you get a plus pi sine of 1 plus pi. So ugly, but the answer. Well, we only have one question left to do, and that's us covered everything, which I always find kind of sort of a sad in some way, because it means there's no more new stuff to do. All we're going to be doing is getting ready for our final. But if you're going to finish, you should finish on a blaze of glory. So let's see what question 12 has got for us. It's got pretty much everything you could do to make the question difficult in it. The function p is u squared plus v squared plus w squared. And u is x e to the y, and v is y e to the x, and w is e to the xy. So let's see what they've done. Ugly formula. Having the u's and v's and x's and y's kind of swap places here. Like the x's should be over here and the u values should be there. That is not wrong. Variables can be any letter of the alphabet you like, and you can have functions in terms of u, v, and w, where u, v, and w are themselves in terms of x's and y's. And as strange as that looks, it's actually totally okay. I'm going to do a little change to this guy. I know I'm going to differentiate it, so I might as well set it up so it's ready to get differentiated. And the guy that we're going to do is we're going to find that one, which means that we're going to have to set up the chain rule formula for it. There's the first piece. P is in terms of u, v, and w, so there are going to be 3 pairs. This is the one that gives you the contribution with u. There's the one. Oops. That's meant to say x. Almost get caught out myself there. That's the contribution with v. There, make it much prettier. Differentiate this with respect to u, and then multiply by this guy's derivative with respect to x. Do it with v, this guy with respect to x. Do it with w, this guy with respect to x. So if you differentiate this with respect to u, you'll get 1/2 u squared plus v squared plus w squared to the power of -1/2, right? That's essentially the power rule. But it is its own little chain rule, isn't it? The inside function is a u squared plus a v squared plus a w squared. So when you differentiate with respect to u, you get an extra 2u. So that expression is just this piece. Now you're going to finish with a du by dx. So you go up here and you differentiate this guy with respect to x, you get e to the y. Now underneath that, I'll put the second one. If you do this guy with respect to v, you will get a very similar looking answer with one major difference. Won't you finish with a 2v? Everything else is pretty much the same. And then you do this guy with respect to x, which actually is that. And then the third one is going to be with w. So you're going to get a half, all this stuff to negative a half, times the derivative of the inside function with respect to w, which gets you that. And then you differentiate this fella with respect to x. And I'm going to do a mistake here. Oh, if you differentiate e to the xy, you get e to the xy.
Y to the x, y, e to the xy.
Times an extra y. Now it's not a mistake. Hopefully, those are the little details that can kill you. Can't you do one of these horribly big questions and you miss out one little y and all WebAssign will tell you is you're wrong and you're just going to throw your hands in the air and say, I don't know how to do these. When really, don't you know how to do 90% of this? It's just one little bit that you missed. And well, it is what it is. Now, this expression, well, it's really three of them, has got a fair amount of stuff that I can do. So I'm going to tidy up each piece separately. So this times this gets me u. The 2.5 cancel out. And I get an e to the y. And the whole thing is going to be over the square root of u squared plus v squared plus w squared. So that's the first one. If I go to the next one, the 2 and that cancel, and I'm left with these three guys. So v, y, e to the x, still over the square root of u squared plus v squared plus w squared. And lastly, these two together, what you're left with is a wy filler, wy, e to the xy, all over the exact same square root as everyone else. So actually I did manage to get it into one line. I wasn't expecting to do that. So far so good. Tidy it up a little bit. Negative downstairs is the square root. Tidy it up. Half power downstairs. Tidy it up. Half power downstairs. Okay, let's look for style points. Anything you can work with here.
And you
Anything.
pull out an e to the y.
This one doesn't have it.
Oh, okay, got it. What about the whole 1 over square root of u squared plus v squared plus w squared?
Yeah, that's about all I can see. Sometimes there's not a lot. And I mean, if there's nothing you can do, there's nothing you can do, right? That's it. It's as good as it's going to get. And of course, they finished with, we don't want this answer. We want this answer when x is 0 and y is 3. Now, you still had to do this, right? You couldn't miss this line out. But now we're going to have to put together a little bit of work. So u is x e to the y, which means it's 0 times e cubed, which means it's 0. So u is equal to 0. Okay. V is y e to the x. That's 3 times e to the 0, which is 3. So v is the number 3. W is e to the xy, which is e to the nothing times 3. E to the nothing gets you 1. Okay, so we got those guys. See what we get now. It's going to be u, which is 0, times e cubed, plus v, which is 3, times y, which is also 3, times e to the x, which is e to the 0. And then it's a w, which is 1, times a y, which is 3, e to the 0 times 3, which is just e to the 0. On the bottom, I have the square root of u squared plus v squared plus w squared. Nothing times z cubed is just nothing. E to the nothing is 1, so that's 9. And e to the nothing is 1, so that's 3. So 9 add 3 on the top gets me 12. And this guy is the square root of 10. And WebAssign is happy with that. Me personally, I don't like square roots in the bottom. So I'm going to call it that guy. Then I can cancel a little bit. And that would be a much prettier answer.